So you have now seen all the three Pythagorean identities. Cosine squared plus sine squared equals 1. 1 plus tan squared is secant squared, and 1 plus cotan is cosecant. Let's now go to problem number 4 to verify this identity here. That tan squared minus sine squared, you have to prove that it's tan squared, tan squared minus sine, you have to prove that it is tan squared times sine squared. The first step here, what do you have to think that? Let's rewrite tan as sine over cosine. And since it's tan squared, so sine squared over cosine squared minus sine squared equals tan before that, don't write that. Now, so we write tan as sine over cosine minus sine. Then, after I saw them coming like this, try to find the common denominator. This is the next step. You have to think
by cosine.
You have to multiply by cosine the both numerator and numerator. So what did you get now? You get sine squared of theta minus sine squared of theta cosine squared over cosine squared. Then, every time, if you want to verify, just think, how can I take a common factor? How can I factorize them? How can I make them have the same denominator? And these are the things that you need when you verify an identity. Then look at the numerator here. You have sine squared minus sine times cosine. Can we take sine as a common factor?
Yes.
Yes.
Yeah, it will be 1 minus cosine.
Take sine as a common factor times 1 minus cosine over cosine.
Is it cosine or cosine squared?
Cosine squared, yeah, I wrote cosine squared. So, so it comes now after I take a sine as a common factor. Then we know that sine squared over cosine squared is what?
This is tan.
Tan, bravo. This is from the tangent identity. It is tan squared times. Now, let's come back here to the Pythagorean. Here, up to now in this lesson, we talk about three identities: the reciprocal identities, the tangent identities, and the Pythagorean identities. The Pythagorean identities, one of them, sine squared plus cosine squared is 1. So if you subtract cosine from both sides, you will get that 1 minus cosine squared is sine squared. 1 minus cosine is sine, and 1 minus sine is cosine. Then here we have 1 minus cosine. Can I rewrite it as sine from this identity here? Yes.
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 So I prove now that it is tan times, or tan squared times sine squared. Is it clear?
But it's like, can you repeat the last step? Like, why? Oh, you prove it that it's equal.
Yes,
Yeah.
I prove that it's equal. This is the question. I need to prove that. This one here.
Okay.
Okay. Now, here, got it? 4. Secant square minus secant squared cosine squared equals tan squared. What do you have to think here? Every time the first step, try to rewrite it as sine and cosine. So secant squared, it is 1 over
1 over cosine squared.
1 over cosine squared, bravo, minus secant squared, which is 1 over cosine squared times cosine squared.
Cosine.
Then here we have it as 1 over cosine minus cosine squared over cosine squared. I just multiply cosine by 1. Then let's rewrite them now here. 1 minus cosine. Oh, before that, let's rewrite it as since they have the common denominator, so we can write it as 1 over cosine squared over cosine squared. Then 1 minus cosine by the Pythagorean theorem,
Cosine.
it is sine.
So sine over cosine equal tan.
So sine over cosine is tan. And sine
And the
squared,
power 2 will
cosine
skip it.
squared. And then, no. Don't, just I told you that sine over cosine is tan. So sine squared over cosine squared is tan squared.
Okay.
Okay.
But teacher, can you just wait a minute to write it?
Yeah, no. Do you have any
Teacher,
question here? Yes, Habiba.
can you repeat the last thing you did?
Okay. Now, after I rewrite it or simplify it, I have, if you look at the denominators here, we have both of them have the same denominator, cosine squared and cosine squared. So in this case, if you have 1 over 4 plus 5 over 4, we write it as 6 over 4. We can add the numerator and take one of the denominators. So here,
Teacher,
yes, Susan,
I think I solved it another way.
you can, there's no problem. And you get the same answer.
Yeah,
Yeah, you can, there's not any problem. Maybe you simplify cosine with cosine.
yeah, and then I ended up with the identity that says 1 plus tan squared theta equals secant squared theta.
Yeah.
And then if you bring the one to the other side, it's tan
Bravo.
squared. So
Bravo.
no, that's it.
You use the cosine square, sorry, secant squared plus 1 equals tan squared. Other Pythagorean theorem. Yes, you can. Bravo. So let's continue here. Now here we have the same denominators. So we keep one of them, as I did here in the numerical fractions, and I take the numerator. Now then, from the Pythagorean theorem of Pythagorean identity, sorry, that's sine squared plus cosine squared is 1. So we can say that's 1 minus cosine squared is sine squared, and 1 minus sine squared is cosine squared. Here now, what did we have? We have 1 minus cosine squared. So we can write 1 minus cosine squared as sine squared. Over cosine. Now, from the tangent identity, we know that sine over cosine is tan. And cosine over sine is cotan. So sine squared over cosine squared will be tan squared. This is what I need to prove.
Teacher?
So what did Susan say?
Just 1 second. هلا حبيبة, is it clear?
Yes, teacher.
Okay. Susan proved it by another way. That's, she simplified cosine with cosine. So she gets it as 1 over cosine squared minus 1. And then 1 over cosine, we know it as secant squared. Then, and from the identities, Pythagorean identities, we know that 1 plus cosine squared is cosecant squared. And 1 plus tan squared is secant squared. So from this identity here, if you take minus, if you move 1 to the second side, so tan squared will be secant squared minus 1. So if she replace secant squared minus 1 with tan squared. That's it.
Okay, thank you, teacher.
Okay. Let's now verify more identities. This is number 47 in your book. Sine squared times tan squared. I want you, I think it's repeated.
Did we do this or not?
Oh, yes, I know. Okay. We prove it. Type now, number 48. Secant minus sine times tan. Prove that it's cosine. Yalla. Number 48. Secant minus sine times tan. I want you to prove that it is cosine. Can you think about it? I'll give me the first step.
Yeah, like we will make secant 1 over.
I just tried to put a paper.
Okay, rewrite secant as 1 over cosine. This is the first step you will think about it. So, minus sine
times
times
sine
tan,
over
which is
cosine.
sine over cosine. Then
Then it will be sine squared.
Then it will be like 1 minus sine squared equal
Over cosine.
over cosine. Now,
Teacher,
1 minus sine squared, without squared, yes,
Equal sine. Equal cosine.
equal cosine squared over cosine. Can we simplify it?
Yeah.
Yes.
Cosine theta.
Cosine. Bravo.
Teacher, here, why didn't we simplify the sign?
How simplify? Sorry, where was?
The first step.
No, it's a sine times sine. I didn't simplify it. They are multiplied. Do you mean here? No, just one second.
Yes.
They are multiplied. I didn't simplify it. Oh, I cannot. I just multiply them. Sine times sine is sine squared.
Teacher, number 41 and 42, they say that express the first trigonometric function in terms of the second. Can you explain this question?
Okay, after I finish this. Is it clear?
Okay, thank you, teacher.
Yes, teacher.
Okay. Now, number 49. Sine theta times cosine multiplied by tan plus cotan. If you multiply them, you must get 1. Now take 1 minute, please try to prove it in your notebook.
Okay, teacher, I did it.
Me too.
Is Hanin here?
Yes, teacher, I'm trying to solve it.
Okay. Who's absent today? Yeah, okay. So sine times cosine, then they are multiplied by tan plus cotan. So tan, we know that it is sine of theta over cosine. Plus cotan, we know that it is cosine over sine. Now they are added. So since they are added, we must make them have the same denominator. So let's multiply by cosine, by cosine, by sine, by sine. So now it will be sine squared of theta plus cosine squared over sine of theta times cosine times sine of theta times cosine. Then we know that from the Pythagorean identity that, or before that, we can cancel sine, sine, and cosine with cosine. And then what did we have now? We have sine squared plus cosine squared. And this is one of the Pythagoreans, which is equal to sine squared plus cosine squared equal to what?
1.
1. The
So now-
teacher,
Yes.
teacher, like you multiplied it by sine and you multiplied the other one by cosine. Why you write it again, the sine and cosine? In the second one.
This is this one. I bring them down.
Yeah, you multiplied them, so why you keep it?
Sorry?
Like you multiplied it, you multiply sine and the cosine, so why you keep it again?
This one here, the denominator.
Yeah, and you multiplied them all, so why you keep it in the last thing?
Yeah, I must keep it. And if you add 1, look at me here. If you add 1 plus 5, you add 1 over 5 plus 7 over 5. What's the answer will be?
2 over 5.
8 over 5. Okay, so you
Oh,
keep the
yeah,
denominator. You keep the denominator. Here I have the cell. I must keep the denominator. This is the denominator. I must keep it.
Yeah, teacher, I get you about this, but I mean, like, you multiplied them by sine and cosine, right?
Okay.
Okay, but then you keep them the sine and cosine again before the parentheses. So why? Like, since you multiplied them, you should skip the sine and cosine now.
بس مش فاهمة.
Teacher, you multiplied like sine by the tan and the cosine by the cotan, right?
I multiply.
But then
Wait.
Yeah.
I multiply what?
you multiplied sine tilde by tan tilde and cosine by cotan, right?
Okay.
Okay, but then you keep them. You keep the sine and the cosine. Why? In the end, you keep the sine and the cosine. Why you didn't skip them? خلاص, since you multiplied them by the tan and the cotan. Like, after you distribute them, why you keep them again in the same place?
Where I distribute them?
By the tan and the cotan.
Miss tan is sine over cosine. And cotan is cosine
Yeah,
over
and
sine.
multiply them.
I
by sine.
multiplied them
And
here
then you
to
multiply
make them have the same denominator.
It's not just because of the sine and the cosine before the parentheses. Like, you didn't distribute the sine and the cosine.
No, I told you they have here, since they are added, so we must make them have the same denominator. To make them have the same denominator, I just multiply cosine with sine and sine with cosine.
Oh, okay. I thought that you distribute them by the sine and the cosine.
No, here you have it as cosine you prove it as sine over cosine, we write it, sorry, as sine over cosine plus cosine over sine. Now, you want to add them, but the denominators are different. To make them the same, you multiply here by sine, up by sine, and here cosine by cosine. Why? In order to make them have the same denominator. Now, this denominator, write it here, sine theta times cosine theta. And up, sine times sine is sine squared. And cosine times cosine is cosine squared. And then I simplified them with this. So then sine plus cosine is 1. And you multiply sines and cosines. Why you simplify it? Yes.
Okay, so teacher, the one that is down, you didn't simplify it, right? Like, just write sine times cosine. Don't make it sine squared times cosine squared.
Where?
Because you want to make it the same. Okay, teacher, I got it. Thank you.
Where do you ask this, please? Can you repeat? Where sine squared
No,
to cosine
teacher.
squared?
Okay.
I
got it.
Okay. Now, number, let's choose now number, just one second here. Number 50 here. I write it for you here. Number 50. 1 minus sine theta over cosine is equal to cosine theta over 1 plus sine. I want you to prove that 1 minus sine over cosine is equal to cosine over 1 plus sine. This is number 50. Now, some of these questions here, you need to what? You ask yourself, I cannot simplify 1 with cosine, and I cannot simplify sine with cosine. I need to think about it. And some of you say, teacher, so I can prove that I can say that it's 1 over cosine minus sine over cosine, and then it's secant minus tan. This is true. If I ask you that, prove that 1 minus sine over cosine is equal to secant minus tan. But here, I want you to prove that it is cosine over 1 plus sine. So now, some of them, as I told you, you need to find to factorize. Some of them you need to find the same denominator. And some of them you need to bring thing that can help you to solve the question. Now, here we know that,
Teacher,
yes,
is it made by cross product?
by, sorry, what?
I was about to tell
Is
you.
it cross producted first?
No, here you
Yeah.
have to prove that the first term, just 1 second, the first term is equal to the second term. And you don't use
Okay,
the second term. Don't use it.
So
Here you
shall I
have
multiply it by
أيوة.
1 plus sine, like we multiply the other side?
But if you multiply up by 1 plus sine, you must multiply down with 1 plus sine in order to don't make any change with the question.
Teacher, can you just move them? Like, can you just remove the minus and make it minus times all of them 1 plus sine?
Wait, what?
Like, remove the minus by making minus times 1 minus sine. I mean 1 plus sine.
Remove the minus?
Just remove the, yeah, like just
How
remove
can I
it.
remove it?
I can make it minus 1 times all of them, which is 1 plus sine. Like we did in the, like,
no, let's start here. So
no?
1 minus sine over cosine. Here in everything, as you remember, sometimes if you need to multiply or make any change with the question or with the expression, if you multiply the numerator, you must multiply the denominator in order that like you multiply by 1. In other words, I have it as 1 minus sine theta over cosine. If I multiply it by 1, this one, I mean like if by the identity, I didn't make any change. So then here, this one, since I need to use the Pythagorean theorem, I can rewrite 1 as cosine over cosine. This is from my mind. I think that, okay, they are not added. They cannot be simplified. They cannot be factorized. So what I have to do, I need to bring something from my mind in order to help me to solve the question. I have cosine. So let's multiply by something you need. Sometimes you multiply by 1 plus sine over 1 plus sine. If you see that can help you, continue. I see that if I multiply by the denominator by cosine and the numerator by the cosine, I will get this. It can help me. Then 1 minus sine times cosine over cosine times cosine, which is cosine squared. Then just 1 second here. Then The second step now. So I have it now as 1 minus sine times cosine over cosine squared. Now let's get back to the Pythagorean theorem, or Pythagorean, identity. We know that 1 minus sine is cosine. 1 minus sine squared is cosine squared. So I can rewrite cosine squared now as 1 minus sine squared. And up, just leave them as 1 minus sine times cosine. Then after that, did you remember that's 1 minus x squared, okay, which can be simplified as 1 minus x times 1 plus x, the perfect form, the perfect
Yeah, so it will be,
so
yeah, so
here
it
now,
will be 1
just wait,
minus
yes,
sine.
wait a minute, please, Rose. So here now I have 1 minus sine over 1 minus sine squared. So then here now I can rewrite 1 minus sine squared as 1 minus sine times 1 plus cosine. It's like sorry. I can write it as 1 plus sine times 1 plus minus sine. Hello, 1 minus sine squared, it's the perfect square formula. It is 1 minus sine squared, it's 1 minus x squared. It can be written as 1 minus x times 1 plus x. Here we have the same, but with sine now. So it likes 1 minus sine times 1 plus sine. And up here, we have 1 minus sine times cosine. Then we have simplified 1 minus sine with 1 minus sine. So I will get cosine over 1 plus sine. That's what I want to prove. Is it clear?
Yeah.
Is there any question?
Yeah, I'm just like absorbing it.
Yeah, and here, as I told you, I give you new ideas, and you have to think out of the box. You have to think, what can I do? Sometimes you have some of them like this. How can you simplify it?
Sine times sine plus 25 sine. Plus
Above
25.
Sine squared plus 2 sine theta plus 1 over sine theta times sine theta plus 1.
Isn't like above same as saying sine theta plus 1 between parentheses to the power
Bravo.
2?
So what did you do?
I returned it to its binomial form.
Bravo. Here, she said that it's like x squared plus 2x plus 1. So I can open 2 parentheses, like to factorize the polynomial, like sine, then plus 1, give me 2 numbers. If you multiply them, you get 1. If you add them, you get plus 2. They are 1 and 1. Over sine theta over sine theta. Then simply cancel them. So you will get as a sine theta plus 1 over sine theta. And then, as an example, you can prove that it is 1 plus 1 plus cosecant, yes. If you need, just here, I give you this idea here that sometimes you need to factorize it as a polynomial.